Okay, for what we have in problem number 1, we are looking at integrating the ratio 3 all over 16x squared minus 9 dx. And this is a problem that is going to involve partial fraction decomposition. Here we have 3 over a difference of squares, and as we factor the denominator, okay, we end up with the ratio 3 all over the product of 4x plus 3 and 4x minus 3 dx. And for the ratio, again, we are looking at forming partial fraction decomposition. So for what we have in the formation, okay, we can write the original ratio. Okay, you can write this in factored form or as it was originally, and we are going to write two distinct fractions where the denominators are going to be the factors of 16x squared minus 9. So taking apart, we can let a be 4x plus 3 as the denominator, and let b be over 4x minus 3. And as we look at clearing away the fractions, multiplying everything out by 16x squared minus 9, or in other words, both 4x plus 3 and 4x minus 3, okay, we're going to have for the fraction with a as the numerator, okay, 4x plus 3 will clear out and will be multiplied by 4x minus 3. And as for b, if it is over 4x minus 3, multiplication by the least common denominator, okay, it's going to cancel out 4x minus 3, but you will have b distributed over 4x plus 3. And so for what we have in the ensuing development, okay, this is the equation that is going to develop. And we have two unknowns with the numerator values of a and b. But the nice thing about this problem is that we have, with the x factors attached, okay, we have two distinct zeros, okay, where we have from 4x minus 3 and 4x plus 3, we have respectively 0 values of 3/4 and negative 3/4. And so if we take and utilize these equations, okay, and we can solve for a first as we zero out b, and so this will be made possible by setting x equal to negative 3/4. So upon substitution, okay, we have 3 is equal to a, okay, now 4 times negative 3/4 is going to be negative 3, minus 3 is negative 6, and again 4 times negative 3/4 will be negative 3 plus 3, so b is going to be zeroed out. And so for what will follow is that we have 3 is equal to negative 6a, and as we divide both sides by negative 6, okay, we'll end up with a at negative 1/2. Okay, so we have for the numerator value, okay, we have a equal to negative 1/2. And as we turn the tables, okay, this time zeroing out a and solving for b, okay, this can be done by setting x equal to 3/4. Okay, so we have this time a is going to go out, and this time b is going to have the coefficient of 6 as we substitute 3/4 for x. And so we have that 3 is equal to 6b, and then we have that the value of b is going to end up at 1/2. Okay, and so with the values of a at negative 1/2 and b at positive 1/2, okay, it's going to turn out that for what we have in the setup ratios, okay, going back to this part, we now have the values of a and b, and now instead of complex fractions, okay, we can move the value of a over to the front, where we have negative 1/2 times the quantity of 1 over 4x plus 3, and then we have plus 1/2 times the quantity of 1 over 4x minus 3. And you can either leave it as such, okay, or you can distribute the 2 over, saying we can write this as negative 1 over 8x plus 6 plus 1 over 8x minus 6. And so for what is going to result, and again the layout for the integration can be carried out in different ways, and I will show you 4 distinct ways upon which you can apply your answer. Okay, but if we have these ratios, we can say that 3 over 16x squared minus 9 dx is equal to the negative of the integral of the reciprocal of 8x plus 6 dx, and then we have plus the integral of the reciprocal of 8x minus 6 dx. And considering that the derivative of both of these denominators is going to go to 8, we're going to have natural logarithmic terms whereupon we consider the division by 8 if we take the natural logarithm of the denominators. And so for what is going to ensue is that we're going to have negative 1/8 times the natural logarithm of 8x plus 6 plus 1/8 of the natural logarithm of 8x minus 6 plus a constant. Okay, this is one form upon which the answer can be written. And also, using the logarithmic properties, you can also write as 1/8 of the natural logarithm, where we have the attachment of the positive term 8x minus 6 all over the attachment of the negative natural logarithmic term. And if you notice in the ratios, we can simplify as 1/8 of the natural logarithm 4x minus 3 over 4x plus 3 followed by the constant. And had you kept the original ratios, okay, of 1 over 4x plus 3 and 1 over 4x minus 3, as opposed to having distributed the 2's over 4x plus 3 and 4x minus 3 to get 8x plus 6 and 8x minus 6, had you gone ahead and done the integrals over the reciprocals of 4x plus 3 and 4x minus 3, okay, your answer could have ended up in this particular result. Okay, so we have 4 distinct possibilities. So we have, again, this is one version, this is another, and then we have again 1/8 of the natural logarithm of 4x minus 3 over 4x plus 3 plus a constant. And again, you can write as a difference of logarithms. Okay, and alright, so we are not limited to just one possibility. And if you were to apply numerical integration, you would have identical values throughout.